Hello, today I will be discussing solid-state drives. Here we have a picture of a standard hard disk drive. Labeled are the parts that make the drive work. All these moving parts wear over time, and they also create excessive amounts of heat. A more recent alternative to a hard disk drive is a solid-state drive. A solid-state drive does not have any moving parts. A solid-state drive consists of several chips of flash memory, a controller chip, all attached to a printed circuit board. The one thing that a hard disk drive and a solid-state drive may have in common is the SATA interface. The SATA interface is what connects the drive to the computer. There are also hybrid drives on the market that combine a hard disk drive and a solid state drive. As you could see, it is simply a hard disk drive with a printed circuit board laid over it. The controller is an embedded processor that bridges the flash memory to the host. The controller fulfills data requests from the host. The performance and features offered by the SSD are determined by the controller. All modern SSDs use NAND flash memory as a form of storage. Each of the flash memory chips consists of millions of memory cells that store voltage. This voltage is binary, either in an on or off state. There are two types of NAND flash memory chip: multiple layer cell and single layer cell. An MLC cell can hold more than one data bit. An SLC cell can only hold a single data bit. MLC chips are used in consumer-grade SSDs. MMC chips allow more storage in a smaller space, which makes them more cost-effective. SLC chips are used in enterprise-grade SSDs. They are much faster, more accurate, and more energy efficient. Having multiple values in each cell makes them harder to get a fix on, thus creating more overhead, which makes MLC chips less efficient. There are some issues that come with using NAND flash memory. NAND flash memory can only be written to a finite number of times before it becomes unreliable. The lifetime of each cell is known as the program erase cycle, or PE cycle. NAND flash memory cannot be overwritten. It must be erased before it can be written to again. Cells are grouped together by pages. Pages are grouped together in blocks. Data can be written page by page, but can only be erased block by block. The controller uses wear leveling to maximize the lifetime of the drive. Wear leveling makes sure PE cycles are distributed evenly. The chips are used cell by cell before the first cell can be written to again. When a user deletes data on an SSD, it is actually not erased right away. The data is marked as stale or invalid. Before a block can be erased, any pages with good data have to be relocated to another block. The process of moving data and erasing marked data is known as garbage collection. Garbage collection is performed by the controller. The process of data being rewritten from one place to another causes write amplification. Write amplification means that the actual amount of physical information written is more than the logical amount attended. This reduces the number of PE cycles. On a SSD, there is space reserved for the controller that is not available to the user. This space is used for features such as wear leveling and garbage collection. This space is typically between 7 and 28% of the drive's capacity. This results in drives that come with unusual capacities such as 120, 240, and 480 gigabytes instead of the traditional 128, 256, or 512 gigabytes that you would see in a hard drive. So, as you have learned, there are some underlying issues with a solid state drive, but overall, a SSD is still going to outlast and outperform an HDD. The biggest thing that's going to hold you back at this time is the dramatic price difference. While an HDD might cost you about 24 cents per gigabyte, an SSD may cost you roughly $2 more per gigabyte. And that concludes today's discussion.